got an order to test the tie point for Cajun, and so what we want to do is see what meter service is being used to meter this site. And we can see we're using a Landison gear meter and one of those little Westinghouse test switches. So let's go to the back, identify this as our tie point metering. You can see that 3 potentials are being used, and you can see that we have 3 currents. So we know this is going to be a Form 9 metering because we're using the 3 currents and potentials to meter. Okay, and if you get on the back, you can look and see at the block down there that all available points are being used on that test block. Okay. When we came in, we called CTOC, but there's a note here that says if you make any changes on here, you have to call CTOC and let them know. But the first thing I want to do is take a picture of the meter readings. We need a picture of the meter readings in case something happens and the meter goes blank. We'll have it as our records. The next thing we're going to do is look at the bottom of the test switch and see where my currents are aligned, because plenty of these Westinghouse blocks are made differently. So if you stoop low enough, you can see that we have the 2 blacks to 2 greens next to each other and the 2 reds sitting next to each other. So these are going to be our currents. These 3 separate ones are going to be our potentials, and that's going to be my common meter. Ben's down there, he's got to get up close to see because the connections are so tight. So right now he's going to hook the white to the common. We'll hook his brown, which you could have done first, but it doesn't matter as long as you get your brown. Okay, now he's got to hook a potential. Very tight when you're pulling with these, so you really got to pay attention to what you're doing because you do not want to cross phases. Okay, so he's got all 3 potentials hooked up. Now he's got to wire his currents into the test switch. He's opening the outs to the currents so he can stab the blade into it. Ready to test the meter, we need to hook the optoprobe onto it. We had to take the cover off to find the pulse on here, and because there's a sticker in the front of it. But we're pulsing, we're testing the meter right now as we go. We already inputted all the information in it, and now we're going to go through this and see to make sure that it's wired correctly. Okay, here we have the vectors. Voltage A associated with current A, voltage B associated with current B, and voltage C associated with current C. What I do is I always carry the previous report just to double check to make sure nothing's changed. That was last year's meter test, and this is this year's meter test. We can see the load is balanced on here by looking at the currents and the voltages, and we can see that voltage was 66. If I turn the kit off, it gets corrected to where it needs to be. And that's how we're going to test the meter, with the voltage power supply off. Okay, so let's go ahead, continue, and we'll wait for the meter to pulse. The meter pulses, we're going to go ahead and start the test. All right, the meter's finished testing, ran 10 revolutions, and it came up 99.957. That meets our standard. Now we're going to go ahead and burn the CTs.